Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session.
So we're going to start with the first one. It's a grade 9 math question. So it's dealing with the volume of a pyramid. So to start off, we will just write out the equation for the volume of a pyramid. So we have the volume is equal to base squared times height divided by 3. So right now we have the base, but we don't have the height. We have the slanted height. We don't have the actual height. So we have the slant height, which is 9, right? But we also have the distance between the slant and the middle. So the middle will be exactly in the middle of the pyramid, and that we can say is exactly half of 5, which is 2.5. So we know this is a right angle triangle, so we're trying to find what height is, so we can use the Pythagoras theorem to solve this. So we can say 9 squared is equal to 2.5 squared plus h squared. So my h is going to be the square root of 9 squared minus 2.5 squared, which ends up being 8.64 centimeters. So that's my height. So I found out my height. Then I'm just going to plug it into my volume equation. So once again, that's base squared height over 3. And my base was 5, so 5 squared. My height is 8.64 divided by 3, which is going to give me about 72 centimeters cubed. So that's my volume. This is an elementary math question. So we're dealing with a pie chart. We have to fill in the missing information and create a pie chart. So we're given a bunch of values, and we have to essentially make this pie graph. So we'll convert these values into percentages first, then we'll convert them into degrees. So if we want to convert 380 into a percentage, we need to do 380 divided by what your total is. So it's 580 in this case, times 100. So that's going to give you approximately 65. So I'm just going to leave it as a nice rounded number. So my percentage is going to be 65 degrees. And my food lost in production is, again, I'm going to do the same steps for all of them. So I have, again, 145 over 580 times 100, which ends up being about 25%. So this becomes 25%. And then 55 over 580 times 100 is going to be about 9.5, about 10%. So I'm going to round out to be 10%. So I found the percentages of all these groups. Next thing I should be doing is converting them into degrees. So I know a full circle is 360 degrees. So I need to find 65% of 360 degrees, right? So all I'm going to do is I'm just going to do 360 times 0.65, which gives me 234 degrees. Do the same for all of them. So 360 times 0.25, which gives me 90 degrees, and 360 times 0.1 to give me 36 degrees. Right. So then I know what the degrees are. I can basically plot my pie chart. So one of them is going to be 90 degrees. So this will be food lost in production. And then there's going to be 36 degrees, which I'll say is this. I'll just make it red. That's not. There we go. And the rest of it is just going to be the bigger degrees, which is the food eaten, which was 234 degrees. So the next question is dealing with is a grade 12 calculus and vectors question. So it's asking me to differentiate the function y equals cos of sine 2x. So when you see this, you should immediately think, oh, I have to use the chain rule because I have a function inside a function. So I have y is equal to cos sine 2x. So my chain rule tells me that if I were to take the derivative of this, I take the derivative of the outside function, so the outside function's cos. So the derivative of cos is negative sine, so I put negative sine, and I'm leaving the inside function the way it is, so I'm leaving sine 2x. But I'm going to multiply my derivative that I got by the derivative of the inside. So the derivative of sine 2x I can do separately and multiply it in after. So this is going to give me the derivative of sine is going to be cos. So I have cos, but I have 2x again. It seems to be a function inside a function again. So I take the derivative of the outside and multiply by the inside. So cos 2x times 2, because the derivative of 2x is just 2. So I'm going to put all this inside here to give me cos 2x times 2. Then I can simplify this to be 2 negative 2 sine 2x times cos 2x. And I'm going to leave it the way it is. So this is a grade 11 functions question. So we're asked to plot the sinusoidal function. So the function given is y is equal to half cos x minus 180 plus 1. So right away we should be getting some important information from that graph. So the first thing we can get is what is the amplitude of my function, and that's just going to be my a value, which in this case is 1 over 2. I can also see what's my axis of symmetry, which is given by this plus 1, so it's going to be 1. And then I have a phase shift, so I'm just going to say PS for phase shift, and that's 180 degrees to the right. Right? And if there's a k value, my k value is whatever my x is multiplied by. I don't have a k value, so I'm just going to say 1. So if my k value is 1, then I know my period is going to be 360 divided by my k. And since my k is 1, my period is just going to be 360. Right? So I know my cos function usually gets split up into 4 parts. So this is what it usually looks like. I have 4 parts like that. So I can figure out what the distance of each of those 4 parts are by just doing 360 divided by 4 to give me 90 degrees, so that each component of my graph is going to be just that 90 degrees. So let's go ahead and draw a rough sketch for what we have. So the information I have is there's an amplitude of 1 over 2, there's an axis of symmetry of 1, there's a phase shift of 180 degrees to the right, and I know my period is 360. So if I were to draw this, my axis of symmetry means it's where my function is symmetrical throughout, so it's just gonna go up and come back down to that value. So I know what a cos function looks like. I'm just gonna use a different color. So it starts at the maximum, it goes down to the minimum and comes back up, and that distance will be your period. So in this case it's 360, right? So my axis of symmetry is 1, so that's why I brought up all the points up by 1. And my amplitude is half. That means from 1, my maximum most value is going to be 1.5. My minimum value is going to be 0.5. Right? So if I draw the original cos function, I start at the maximum, I come down to the very bottom, and then I go back up, and that's 1 period, and that should be 360 degrees. Right? So it's going to look something like that. Right? But we still didn't account for the phase change. So what the phase change does is we have a phase change of 180 degrees to the right, meaning each one of these points will be translated 180 degrees to the right. So the exact middle is going to be 180 degrees. So my maximum most point will be translated to 180. Right? And then my minimum most point again will be translated to 180. My maximum point, which makes a full period, will be translated to 360 plus 180. Right? So 520 will be over here. So this will be 540. So what I end up with is a function that looks similar to this. And then if I continue this on, I know I have to go back down over here, and I can just continue this on and on and on. Right? The important thing is that I recognize that I have a phase shift of 180. I have an amplitude of 0.5. Right? And I have an axis of symmetry at 1. So that's accurate enough, and I'm just going to end it over there. So the next question is from grade 11 functions. It's an exponential equation, so we're solving for x. So we're given 3 to the power of 2 minus 2x is equal to 1. So what we try to do is get the bases to be the same. So we try to get 3 as a base of, sorry, try to get 1 as a base of 3. So we have 3 to the power of 2 minus 2x. And the only way we can get 1 would be 3 to the power of 0, right? That's the only way we can get the bases to be the same. So once we figure that out, then we're going to make the exponents equal to each other. So 2 minus 2x is equal to 0, and then 2 is equal to 2x, so x will be just 1. Right? So the easiest way to solve these kind of questions is to try to get the equations to be in the same base. So I tried to get 1 as a base of 3, and the only way to get that is if 3 was raised to an exponent of 0, because anything raised to an exponent of 0 is just going to be 1. So the next question will be the grade 10 math question. So it's asking me to find the values a and k such that the parabola passes through a point 1 and 3 and 2 and negative 3. So what we do is we rewrite this equation, y is equal to ax squared plus k, and we're going to substitute the points into this. So 1 and 3 first, so I'm going to substitute 3 for y and 1 for x. And I'm going to just simplify as much as I can. So I have a plus k. So I came up with one equation. I can come up with another equation by plugging in the second point. So my second point is the 2 and negative 3. So I'm going to plug in negative 3 is equal to a 2 squared plus k. This simplifies to negative 3 for a plus k. Right? So then we can solve this because we have two equations with two variables. So we can either use substitution or elimination to solve this. So I'm just going to use elimination. So 3 is equal to a plus k, and negative 3 is equal to 4a plus k. So I can just subtract the two equations from one another to give me 3 plus 3 is going to be 6, a minus 4a is going to be minus 3a, k minus k is going to be 0. So that's the point of elimination. I'm trying to eliminate one of the variables, so I decided to eliminate k. So then I can go ahead and simplify for my a value. So a is going to be 6 over negative 3, or a is going to be negative 2. So we found one of the values. We found a. How do we find k? We can plug it into either one of the two equations that we came up with. So I can plug it into the first equation. So I have 3 is equal to a, which is now negative 2, plus k, and then k would be 3 plus 2, which is 5. So whenever you encounter these kind of questions, try to see if you can get two equations and then try to use substitution or elimination to solve them. If you have two unknown variables, you need two equations to solve them. If you have three unknown variables, you need three equations to solve them, and so on. Right, so once again, if you have any questions, feel free to send them in. We'll be happy to help you out with them. So we're going to move on to the next question. So this is a grade 12 calculus and vectors question. So it's asking us to plot this function using curve sketching, meaning we have to use first derivatives, second derivatives, using the intervals for first and second derivatives to plot this. So we might not need to use all the we might not necessarily need to use a second derivative if we have enough information from the first derivative already. So let's go ahead and get the easy points first. So the first one is, where's my y-intercept? So that is when x is equal to 0. So when I plug that in, I get cos of 0 plus sine of 0, which is going to be 1 plus 0. So f at 0 is just going to be 1. So my y-intercept is when my coordinate is 0 and 1. So the next thing I can do is find the derivative for this function. So f prime is going to be negative sine x plus cos x. Right? And then what I can do is set my derivative equal to 0 and find my critical points. So I see when is it equal to 0, I have sine x plus cos x. Right, so I can bring the cosine over, so I have sine x is equal to cos x. And then I can try and isolate this to give me, no, let's move the cos to the other side to give me sine x over cos x is equal to 1, and then this is a function that I know is just tan x is equal to 1. When is tan x equal to 1? So I know that tan x is equal to 1 when x is equal to either pi over 4 or when it's 5 pi over 4. So I found two critical points right now. So if I evaluate my function at these critical points, so I'm looking at my original function and plugging this in. My original function was sine x plus cos x. If I plug these in, I should get square root 2. And then if I plug in 5 pi over 4, I should get negative square root 2. Right? So what I should do is draw up an interval table. So what happens from 0 all the way up to 2 pi. So I'm going to do 0 to pi over 4, pi over 4 to 5 pi over 4, and then 5 pi over 4 to 2 pi. What is happening in between these? So what I do is I'm performing the first derivative test at this point, so I'm finding out when is my derivative, what is my derivative, is it positive or negative during these intervals. So what I can do is just plug in a value between these intervals into my derivative, and I find that it's going to be plus, minus, and plus. So I'm just skipping some steps for the sake of time. What I'm doing is just picking a number between 0 and pi over 4 and plugging it into my derivative. I'm just going to rewrite what my derivative was. It was negative sine x plus cos x. So I'm plugging them into this function. Right. So I found out that it's plus when it's between 0 and pi over 4. It's negative when it's pi over 4 to 5 pi over 4. And then it's positive from 5 pi over 4 to 2 pi. What is that telling me? That's telling me that my rate of change is positive over here and over here, but it's negative between pi over 4 and 5 pi over 4. So I feel confident enough that I know I have enough information to plot this. So I know my y-intercept, again, if we scroll back up, that's what I found first, which was just 1. So I'm going to plot that point. So if this is 1, I have a y-intercept over there. It's going to extend this graph a little bit. Right. And then I have critical points at pi over 4 and 5 pi over 4. Right. I should condense this just to show the whole period. So I'm just going to say this is 5 pi over 4, and all the way here is going to be 2 pi, and somewhere here is going to be pi. So what do these 2 points, the critical points, mean? They're going to be one of my local min-maxes. So I have square root 2 and negative square root 2. So the maximum point is going to be when it's when it's square root 2, and my minimum point at 5 pi over 4 is going to be negative square root 2. So I know my maximum is going to be at pi over 4, my minimum is going to be at 5 pi over 4, and I know enough to graph this. So I know it's going to have a positive rate of change from 0 to pi over 4, so I'm just going to start going upwards until I hit pi over 4, and from pi over 4 to 5 pi over 4 I have a negative rate of change, meaning it's going to be going downwards until it hits 5 pi over 4. And afterwards, between 5 pi over 4 to 2 pi, it's just going to be a positive rate of change. So it's a little distorted, it's not exactly accurate. But the main idea is that I found the x-intercepts, and I found the critical points, and I found what the values for the critical points were, so it's going to tell me is it a min or max, and then I evaluated the intervals between the critical points. Is there a positive rate of change? I can see that by looking at my slope for the tangents. So it's positive between 0 to pi over 4, it's negative from pi over 4 to 5 pi over 4, and it's positive again until 2 pi. Right? So I could have used the second derivative to see where my points of inflection are, but my point of inflection, because you should have worked with sinusoidal functions for a while, it should be exactly in between the 2 critical points. So we can find that by just doing 5 pi over 4 plus pi over 4, divide that by 2. So there's a question about growth and decay. So how can you know the y, a, b, and x? So I'm just gonna draw out what the function usually looks like. So this is the usual exponential function equation that's used to model growth and decay. So a is typically your starting amount, it's your initial amount. And b is your rate of change, so it could be increase or decrease, so it could be a growth or decay. Right? And then your x is how many times is that increasing by. So if it's an yearly increase, then x will tell you how many years it's been. So b, if it's a growth, it's going to be 1 plus whatever the growth percentage is. So if it's growing by 15%, for example, I do 1 plus 0.15. I'm changing the percentage into a decimal and I'm adding it to 1. Conversely, if we're talking about decay, we're not adding, we're subtracting from the 1. So we're going to do 1 minus something. So if we have a decay of 25%, for example, we do 1 minus 0.25 to give me 0.75. Right? So growth functions always should have 1 plus something, or your b value should always be bigger than 1. So this is a grade 12 data management question. It's talking about intersections. So there's 2 events A and B such that the probability of A is 0.62 and the probability of A and B happening is 0.18. What's the probability of A and not B happening? So what we can do is write down the equation that regards to the P of A and B. So P of A and B is going to be the probability of just A multiplied by the probability of B or A. So then this is going to be, I already have my P, I have 2 of these. So this is 0.18, this is 0.62. I can find out what this is. Right? So I can just divide both of them by 0.62, so I have the probability of B, A, that's going to be 0.18 over 0.62, which gives me 0.29. right? And the probability of B not of A is going to be 1 minus what we have found, so it's probability of B and A. So that's going to be 1 minus 0.29. In other words, it's going to be 0.71. Right? And we need this because the probability of A and not B is going to be the probability of A multiplied by the probability of not B and A. So this is going to be 0.62, 0.71, multiply them together, we should get 0.44. We're just manipulating the equations for the AND to try and find a correlation between them so we can find out what P, the probability of A and not B is. So in this question, it's asking me to simplify using exponent laws. So we have 15, I'm just going to rewrite this, where we have 15 m minus 2 and 2 over 3, and then 24 m minus 2 and 2. So exponent laws are essentially what happens when you have the same base with different exponents either being multiplied or divided. How can I simplify them? So the numbers, I'm just going to leave them the way it is. But the exponents, I can simplify them because I have the same base but different exponents being divided. What happens when they're being divided? I'm going to subtract the exponents from one another. So I have minus 2 minus minus 2. Right? And the same goes for the n, so I have n 2 over 3 minus 2. So this should give me 15 over 24, with m of minus 2 plus 2 is just 0, and n of 2 over 3 minus 2 gives me minus, it becomes 6 over 3, which simplifies to 15, 24, n of minus 4 over 3. Right? If we want just positive exponents, we can bring the n to the bottom, so it becomes n 4 over 3. Right? So one of the exponent rules is that if there's an exponent of a negative number, that means we bring that to the denominator to make that a positive. So that's about all for today. So thank you for tuning in. Hope this has been helpful. Once again, if you have any math questions you want any help in, you can send them in and we'll be happy to help you out with them. So this has been T from Ask Zylor. I hope you have a great night.